Is there anything we needed to address? If not, I'm going to share my screen and go directly to the last section of this chapter that I would like to go through. I don't think this is really necessary to go through graphing these functions. I just want to mention something about quadratic functions. And then I want to review the exponential rules. These are very important. But I just wanted to say something about the quadratic function. So polynomial functions are very friendly. They are defined everywhere, no problems ever, ever, ever. And what are they? Well, linear is the first one that we graphed using x and y intercepts. What is the next level? Quadratic. So this is the first degree. Of course, this is the second degree. And it goes on from here. Cubic, fourth degree. Cubic, of course, is third degree. And so on and so forth. I just wanted to emphasize the characteristics of the quadratic. The quadratic function, again, this is algebra. This is a refresher for you. Even if it's not, I'm going to talk about it anyway. A quadratic function looks like this, or like this. The graph is called a parabola. It either has a minimum or a maximum. It cannot have both. And this is also called, both of them are also called vertex or vertices, plural. The vertex is a minimum here. The vertex is a maximum here. The quadratic function is symmetric. It has an axis of symmetry. And the axis of symmetry is a vertical line passing through the vertex. Okay, what we also need here is something called the quadratic formula. I think that this is way beyond this, way before the scope of the course. So I'm not going to talk too much about it, but I will show you how to use the calculator directly to solve a quadratic equation. But the quadratic equation has to look like this. If it's not in this format, meaning the leading coefficient with x squared plus the middle coefficient with x plus the free term equals 0, we cannot use the quadratic formula. And what is the quadratic formula? X equals negative b plus or minus the square root b squared minus 4ac over 2a. Now, let's choose any quadratic equation from here. Any quadratic equation. And I will show you how to use the calculator directly and not have to worry about the quadratic formula moving forward. Because this is way past, so I'm fine. We're not going to discuss the quadratic formula in this class. I don't think it's a good idea to spend time on that. So let's choose a quadratic equation from here, and I'll show you how to use the calculator to solve it. If anyone would like to choose, if not, I will.
Do 41.
41 is perfect. Let's take a look. So in 41 on page 60, we have 3y squared plus 8y plus 2 equals 0. For a second, it's quadratic. It has degree 2. It's in descending order of the powers of the variable. The leading coefficient, which is a, the middle coefficient, which is b, and the free term, which is c. Okay, I'm going to kindly ask you to turn off your cameras for a second, please. I just need to record this and post it, and I don't want to record anyone's face, camera, etc., etc. So if you want to turn it off for a second. Good, perfect, thank you. So let me share my screen first, and let me see, where's my recording? Record, yes, okay. So with the graphing calculator, you're going to, not all calculators have this feature, however. So if you need me to go over quadratic formula, we can. So there is something in apps, in applications right here. And it's the last one on this page, which is number 9, polynomial root finder. So you click 9 and polynomial root finder, yes. You have to select something that they called order, but it's the degree. So in this case, it's degree 2, but of course it can be any degree, including 10, right? But in our case, it's degree 2 because it's quadratic. It will ask us to enter the coefficients. I will enter 3. I will move on to the next one, which is 8, the middle coefficient, and the last one, which is positive 2, and enter. And I will just click on graph, and it gives me 2 solutions. And that's it. So I'm going to copy that y is negative 0.279, and the other y is negative 2.387. And that's good enough. That's all I needed to record. Stop recording. Yes. I would like to post this for you because we're going to use it several times. That's all I'm asking you to do. Now, in the same token, we can write the quadratic formula. Just for those of you who do not have this feature in the graphing calculator, negative b plus or minus the square root of b squared. Remember, this is always positive. No matter what b is, positive or negative, when I square it, it has to be a positive number, always. Minus 4 times 3. 4 times 3 is 12, times 2 is 24, divided by 2 times a, which is 6. So what I did, I just completed, replaced b, squared it, 4 times a times c, 2 times a. This is a, in our case is 3. This is b, 8, and 2. And when I determine and approximate these two, I'm not going to record this, but I want to show you. Okay, so here's how we do this. Left parenthesis, negative 8, plus the square root of. And you know I like parentheses, so I'm going to put 64. Although 64 minus 24 is 40, so I can just enter it as 40. And then I don't need parentheses. Make sure you come out of the square root, and you divide by 6. And I have to get the same answers. And then I second an entry, so I don't have to type it in again, but I just need to overwrite the plus to a minus. And I have to get the other solution, which was negative 2.387. So this is for you, for those whose calculator does not have the apps feature. Okay, back to what I wanted to show you. I wanted to review the exponential rules. Okay, so the exponential rules, so I'll say same. Exponential rules. So when we multiply two exponential notations, they have to have the same base. So n and m. So my n has 2 bubbles, my m has 3 bubbles. Copy the base and add the exponents. But you have to remember that this goes back and forth, meaning if I see this, I can write this. If I see this, I can write this. So when we multiply two exponential notations with the same base, I don't touch the base. I copy the base and add the exponents. Now, when we divide a to the n over a to the m, we copy the base and we subtract the exponents, and that's always in this order. From the numerator, from the exponent of the numerator, we subtract the exponent of the denominator. Again, it goes back and forth. If I have this, I can write this. If I have this, I can write this. And then the power. A raised to the nth power, everything to the mth power. I copy the base, and this time I multiply the exponents. And of course, it goes back and forth. Now, what happens when the exponent is negative? Please remember, when the exponent is negative, it does not mean that the answer is negative. It does not mean that. So a to negative n is simply 1 over a to the nth power. And again, it goes back and forth. One very, very important rule that you're going to see here a lot is this. The nth root of a to the mth power. It's a mouthful. The nth root of a to the mth power. And you can say, what's the connection? This is a radical. This is a power. What are you talking about? Yes, radicals are powers. Fractional powers. Fraction. An exponent, a base raised to a fractional exponent, or an exponent that is a fraction, is a radical. So this again goes back and forth. This is not a friendly notation. It's cumbersome. It's not easy to work with. This is not easy to work with. This is not easy to work with, to be honest. They're difficult situations. So let's take a look and choose something from here. See, rewrite each to an equivalent as an equivalent expression with rational exponents. All radicals are exponents, but not nice exponents most of the time. They're fractions. Okay, so here we have they are giving us the fractional exponent, or in other words, the exponential notation with a fraction that is the exponent, to change it back to a radical. So these are, they look difficult, they're not difficult, but they're not friendly either. So let's choose from the first set and then choose from the second set. Will anyone like to choose? Will anyone prefer anything?
We do 53.
Yes, of course. So 53, and this is still on page 60, we have x squared plus 3 raised to negative 1/2. So first of all, I see a negative exponent. I'm going to use this notation. A negative exponent is nothing else but a fraction. Do not assume that it's negative. If the exponent is negative, the fraction doesn't have to be negative. It could be. Who knows? It may end up being negative. But do not assume that this makes the fraction negative. So basically, this is 1 over x squared plus 3, as you see, with a positive exponent. And now I see a fraction. See, this is the power of the expression inside, and the denominator is the index. The denominator is always the index. Since here is 2, what index will this radical, because it's a fraction, it has a fraction as an exponent, so it's a radical for sure. But what is the index?
Wouldn't it just be like a regular square root?
Exactly. We don't, by convention, we do not write the square root. It's the only one we don't write. And because the power is 1, there is no need for parentheses and write 1, because the power is 1. Very good. See if we need another example, or we can move on to the next section here. next set of problems.
Could we see number 49?
Absolutely. So we have t raised to negative 2/5, and this is 49. Good pick. Very good. Thank you. So again, this is a negative exponent. It does not mean a negative number. It could, but not at this stage. And this is because the power is a fraction. I know it's a radical. All I need to do now is identify the index and identify the power of the base. Can anyone give us the index first?
Would that be 5?
Exactly, exactly. Very good. And obviously power 2. Very good. Awesome. Any questions? Don't let me move on. If you have any doubts, any questions about anything, please. Please. Okay, moving on.